Let's get into the notes for Module 2, which deals with all different types of absolute value. We start off with absolute value functions. So we learned just overall about functions last module, where a function is an equation that has two variables, an input variable and an output variable. An absolute value function is where now you put a number into the function and the number that comes out is the absolute value of the original one. Most of us know absolute value as the sticks, or whatever you put inside, you get out a positive, and that's kind of what absolute value does. So we'll start getting into this concept of parent points, because as opposed to a line, which the types of functions that you might be used to graphing, lines they were continuous, and the points lined up and went in the same direction. So if you wanted to come up with several points for a line, once you find an original point, you could use slope to find the rest, because the points were all the same ratio from each other. But now in Algebra 2, we start getting into functions that change direction, functions that curve. So we're going to need more than one starting point in order to be able to graph these. So we call those parent points. So if you look at the points that are on your screen right now, what they all have in common is that the y is the absolute value of the x. The absolute value of -5 is 5. The absolute value of -4 is 4. The absolute value of -3 is 3. The absolute value of -2 is 2. Even on the positive end, okay. Remember, absolute value is what it's defined as the distance from 0 on a number line. So distance has to be positive. So whatever you get out of absolute value has to be positive. Absolute value of 1 is 1. Absolute value of 2 is 2. Of 3 is 3. And so on and so forth. So we could use these as starting points. If you were to put these points on a coordinate plane, this is what it would look like. Okay. So when we're going to graph an absolute value function, we consider these to be starting points. Then we're going to identify some transformation numbers. You were also introduced to transformations in the last module. And we'll see how those transformation modules affect the shape of the function. If you were to describe this function in its most basic nature, it looks like a V. So it starts off looking as a V. And we'll see what's going to happen to that V. Is it going to flip? Is it going to slide? Is it going to look tall and skinny? Is it going to look short and fat? And we'll talk about the numbers that are going to do that. So if I get this parent function that you saw up here, which in its most basic is just y equals the absolute value of x, and I put some transformation numbers around it, you were introduced to these before in the last module. Depending on what these numbers are, they could affect the appearance of the function, of the absolute value function. A is responsible for vertical stretches and compresses. If A is negative, it would also cause the V to flip over the x-axis. B is not as common, not as many books use B, but if there were to be a number that's inside the absolute value but outside of a parentheses, notice how both A and B are in front of the x. Then that would cause the V to stretch or compress horizontally or possibly flip over the y-axis. Now, in this particular case, if a V were to flip along the y-axis, it's not going to look any different. It's still going to look like a V. And then finally, H and K are what are in charge of translations. Remember that with H, since there's a negative in front of it in the formula, this negative here, what you're seeing in the function is not really what H is, it's the opposite sign. So if you see an x plus 3 in there, really H is -3. If you see like an x minus 7, well then H is going to be positive 7. And then K is outside of the, any number that's on the outside of the absolute value being added or subtracted, that's going to control vertical translations. It's going to slide the V up and down. When we, in every problem that we do today, we're going to identify what A, B, H, and K are. So just know that the default values, meaning like if these values are not going to actually do anything to the function, A being 1 and B being 1, if you identify that, those can be ignored. It's not going to do anything. H and K being 0, if either of those are 0, then those can be ignored. It's not gonna; those would not change the appearance of the graph. That's the default value of each one. Up in the parent function that you see up here. If I were to identify what A is, what B is, what H is, and what K is, in that parent function before you did any transformations, this is what the values would be. Now, throughout the year, when we perform transformations on all functions, not just absolute value, this is the way that it's going to be done. You get your starting x, and you're going to divide it by b and add h. That's why if b was 1, anything divided by 1 is itself, and if h was 0, anything plus 0 is also itself. But if there's any other numbers there, those have to be applied. And you get the original y, and you're going to multiply it by whatever the a value is, and you're going to add k. Once you apply these transformations, then the new points that you get are going to belong to your newly transformed figure, to the function. In this particular case, h and k is also significant because whatever the value of h and the value of k is where you're going to see a vertex. The vertex is here in the is where the absolute value function changes direction, and that's always going to be located at h comma k. And absolute value happens to be symmetrical. It has vertical symmetry. That axis of symmetry is going to be at x equals h. So if h is 2, it would be at x equals 2. You should have learned already that any equation that just has an x and x equals a number where there is no y is going to be a vertical line. So notice how here, as notated by this vertical line, that absolute value functions have vertical symmetry. Then later on in the module, we'll move away from functions and let's do some examples from the day 6 assignment. Here they want us to predict what the graph of the function g of x is equal to absolute value of 5 over 3 times x minus 5 plus 3 would look like, and then select the graph of the function. So what we want to do in this case is identify our key values, which are a, b, h, and k. Outside the absolute value, here is where a would go, and since we don't see a number, that means a is 1. B is going to be 5 over 3, because that's inside the absolute value, but it's still in front of the x. H, you got to remember, even though it looks like h is negative 5, that negative is coming from the formula, so h is actually a positive 5, and k is 3. So this graph is going to be horizontally stretched or horizontally compressed? Well, with horizontal stretches and compress, it's actually the opposite of with A, where the bigger number means that it's actually going to shrink. So since 5 over 3 is greater than 1, it's going to be a horizontal compress. And we're going to shift, H is 5, so we're going to go 5 units to the right. And K is 3, so we're going to go 3 units up. So a graph of an absolute value that looks where I would focus on the vertex as far as the translation goes. We're going to look for one where the vertex is at 5, 3, which it looks like the only possible ones are going to be A and D. But out of those two, there's only one that has been horizontally compressed. When you horizontally compress, it's going to look tall and skinny. So that would be D. Let's predict what this graph would look like. Let's identify our key values here. A is 9 over 7. B is 1. H is positive 5. And K is negative 4. So we're going to shift to the right. H is what goes left and right. It's positive 5. We have a vertical. Now with A, if it's greater than 1, that's going to be a stretch, as opposed to with horizontal, where it would have been backwards and compressed. So it's going to be a vertical stretch. The 9 over 7 is greater than 1. And then we're going to shift 4 units down because K is negative. Be careful not to put in a negative 4. Distance has to be positive. So we're going to go positive 4 units, but just in the down direction. We look at the vertex. We're looking for a vertex at 5, -4, which the only ones that are possible are B and C. But now I'm looking for one that looks like it's been stretched in the vertical direction, that looks taller and skinnier. So that's going to be B. Select the graph of the function and identify the domain and range. So let's identify our key values. A here is -5/4. B is 1. That's a very common value for B. H is +4, because I see a -4 in there, and I don't see a K, so K is 0. So since A is negative, we're looking for an absolute value function that has flipped over the x-axis. It should be facing down. I'm also looking for one that has the vertex at 4, 0, which there's only one that's possible, and that's going to be B. As far as the domain and range goes, just for future reference, the domain of all absolute value functions is going to be all real numbers, because absolute value functions will go forever to the left and they will go forever to the right. Now the range is limited, but range means where do you go as far as the y-axis is concerned, and this particular one goes as high as 0 on the x, and it does go forever down, which is why the range is all y's less than or equal to 0. Select the graph of the function and identify the domain and range. So here, A is going to be 1, B is 2/7, H is 3, K is 0. So we don't have any reflections here. B is less than 1, so that's going to be a horizontal stretch. So I'm actually looking for something that's short and fat, because if you stretch out in the horizontal direction, you're going to look shorter and fatter in the vertical direction. We're looking for a vertex at 3, 0. So there's only 2 possible ones here that look like they could have a vertex at 3, 0, and that's A and B. But only one looks short, and only one of them looks short and fat, and that's going to be B. The domain is again all real numbers, and since the entire function is contained at the x-axis and above, that's why the range is y greater than or equal to 0. Everything is above the 0 on the y. All right, given the graph of the absolute value function, write the function in this form, where we can tell from the way it's written what they want us to identify is B, H, and K. So they want us to write a function. H and K are going to be the quick ones. Since we don't see an A here, we're going to assume right off the bat that A is 1. H and K we can get from the vertex. This vertex is at -4, 3, so I know my H is going to be -4, and my K is going to be 3. But I have to find B, so I'm going to use an equation to allow me to do that. In order to do that, I got to pick one extra point that I know that for sure the graph is going through. It can be any point you want, but it has to be passing through it. So let's see. It looks. I love the number 0. I love substituting the number 0. So it looks here. I'm pretty certain that this graph is going through the point 0, 11. So I'm going to use that as an extra point. X is 0, Y is 11. But it could be any point other than the vertex. And I'm going to plug those numbers into the formula. So instead of g of x, I'm going to write 11 equals absolute value. Now this is the tricky part. I don't like this 1 over b thing that they wrote there. So I'm just going to write b. Then x is I'm using a 0 for x, minus h, which is -4. So that's going to turn it into a +4. Close it. Absolute value. I'm going to have to move this over because it's not going to fit. Let's write this somewhere where it'll fit on the screen. Let's go over here. 11 equals absolute value b 0 plus 4, close it, and then the k is 3 on the outside. And let's solve for b. 0 plus 4 is 4, so I get 11 equals absolute value of 4b plus 3. In order to solve absolute values equations, this is what we're going to do tomorrow or next class. You got to isolate the absolute value first. So I have 8 is equal to absolute value of 4b. Now the way you remove an absolute value is by creating a compound. So you're going to write two equations. 4b is equal to 8, or you write 4b again, but it could also be negative 8, because the absolute value would turn either one of those positive. If you divide by 4, you get that b is 2, or you get that b is negative 2. And actually, both of these are correct. If you were to put in that b is positive 2 or b is negative 2, technically it's correct, but I believe this book is only going to accept the positive one, so that's what I'm going to put in. They already put the g of x in for me. I'll put the absolute value. I'm going to put in the positive 2, parentheses, x minus h. H is negative 4, so I'll write my x plus 4. Close the parentheses. Now get outside of the absolute value to write k, which is plus 3. We'll check our answer, and that's correct. Last one. Again, here they want me to write an equation, but if you look at the format, now they want us to use an a. There's no b written there, so we're going to assume that b is 1. H and k we can find at the vertex. This vertex is at 6, 5. So h is 6 and k is 5. I can tell by looking at the picture that a is going to be negative. I just don't know what a is. So I'm going to use a through point like I did with the last example. I need to pick a point that I'm very confident that this is passing through. And I think I found one here that I like. So let's use negative 2, 2. I'm going to use an x of negative 2 and a y of 2. So instead of writing g of x, in order to be able to solve for a, I'm going to write 2, because that's the y I'm using, equals the a I'm looking for, absolute value. X is negative 2. H is 6, so minus 6, plus the k, which is 5. 2 equals a. Negative 2 minus 6 is negative 8, plus 5. Now the absolute value of negative 8 is 8, so 2 equals 8a plus 5 minus 5 minus 5. Negative 3 equals 8a. Divide by 8. So I know that a is equal to negative 3 over 8, which makes sense because this looks like it's been flipped, and it also looks kind of shorter and fatter, like it's gone through a vertical compression. So they already have the g of x for me. I'll write negative 3 over 8. Then the absolute value. X minus h. H is 6, so x minus 6. And that didn't go on the inside, so I got to do that again. Absolute value, x minus 6, then go on the outside, plus 5. And that's correct.